So in this video, let's focus on how to find the integral of some basic trig functions, as well as the integrals that result into inverse trig functions. So let's start off with integrals of trig functions. So the integral of cos ax dx is equal to, so first of all, you are going to differentiate this, that is ax, and then you have a. So that appears at the denominator. So you have 1 over a times sine ax plus c. Now you can think of integration as moving upwards and then differentiation as moving downwards. So you realize that when you integrate cos x, you have sine x, and when you differentiate sine x, you have cos x. So integration is moving upwards, so from cos x you move upwards to get sine x, and then differentiation is when you want to move downwards, so when you differentiate sine x, you have cos x. So that is how you can think of integration and differentiation. B, the integral of sine ax dx is equal to, so as usual you are going to differentiate ax so that you have a, and that appears at the denominator. So this time you have negative 1 over a times cos ax plus c. Again, the integral of sec square ax dx is equal to, you have 1 over a. Now when you integrate sec square, you have tan, so we have 1 over a times tan ax plus c. The integral of cosec square ax dx is equal to, you have negative 1 over a. Now when you integrate cosec square, you have cot, so we have negative 1 over a times cot ax plus c. Now if you want to integrate sec ax times tan ax dx, then that is equal to, we have 1 over a times sec ax plus c. And then lastly, if you want to integrate cosec ax times cot ax dx, that is basically equal to negative 1 over a times cosec ax plus c. So having this in mind, let's try to solve a couple of examples. So the first one we are going to talk about, is, let's try to integrate the function 3 over 5 times sec square 2x with respect to x. Now we can think of this as, because 3 over 5 is a constant, we can pull out 3 over 5, and then we have the integral sign, and then we have sec square 2x dx. Now if you integrate sec square ax, you have 1 over a times tan ax plus c. So here we have a equals 2. So if you want to integrate sec square 2x, then you want to differentiate 2x so that you have 2, and that comes or appears at the denominator. So you have 1 over 2 times tan 2x plus c. So let's simplify this. Now we have 3 times 1, which is 3, we have 5 times 2, which is 10. So we have 3 over 10 times tan 2x plus c. Now let's move on to our second example. So for this, we want to find the integral of the function sine 4x plus 3 cos 6x dx. Notice that here we have two terms. We have the first to be sine 4x and the second to be 3 cos 6x. So the best thing to do is to integrate each of the terms separately. So we can say that this whole expression is equal to, so we can say this is equal to, we have the integral of sine 4x dx plus 3, or better still, the integral of 3 cos 6x dx. So let's simplify further. Now when you integrate sine ax, you have negative 1 over a cos ax plus c. So that is this. When you integrate sine ax dx, you have negative 1 over a cos ax. So we have this to be negative 1 over, we have a to be 4, so negative 1 over 4 times cos 4x plus, we can pull out 3 because 3 is a constant, so we have 3 times, when you integrate cos ax, you have 1 over a sine ax. So that becomes 1 over 6. You differentiate this, you have 6. Then cos changes to sine, so sine ax. So we have 6x. And then you can bring your constant. Notice that after differentiating this, we had a constant c here. However, if you add that constant c to this, it is equal to 2c, which is still a constant. So you can either choose to have only one c here, or better still have c plus c. But at the end of the day, you realize that we still don't know the exact value of the constant, so you can simply leave it and then just have one c somewhere here. So now let's proceed with the rest of the solution. So we have negative 1 over 4 cos 4x plus, now 3 goes here once, 3 goes here 2 times. So we have plus 1 over 2 times sine 6x and then plus c. Now let's move on to example 3. We want to integrate the function 5 cosec square 2x dx. So first of all, let's pull out 5, which is a constant. We have cosec square 2x dx. Now when you integrate cosec square ax, you are going to have negative 1 over a, so we have a to be 2, times cot ax, so cot 2x plus c. So we have this to be negative 5 over 2 cot 2x plus c. So to example 4, we want to find the integral of the function 3 sec 2x times tan 2x dx. So as usual, we are going to pull out the constant, which is 3. We have the integral of sec 2x times tan 2x dx. So integral of sec ax times tan ax is equal to 1 over a sec ax plus c. So that simply becomes 1 over 2 times sec 2x plus c. So that's very simple. So we have 3 over 2 times sec 2x plus c. Now to example 5. Given the integral of the function 8 cosec 4x times cot 4x dx, how do we find the integral of this function? So we pull out 8, we have the integral of cosec 4x times cot 4x dx. We have 8 outside, and then integral of cosec ax times cot ax is equal to negative 1 over a times cosec ax plus c. So we have negative 1 over a is 4 times cosec 4x plus c. 4 goes here once, 4 goes here 2 times. So we have negative 2 cosec 4x plus c. So aside from the integrals of the 6 trig functions we've already spoken about, let's look at how to find the integrals of the following. So first, we want to talk about the integral of tan x dx. Second, integral of cot x dx. Third, integral of sec x dx. And then lastly, we have the integral of cosec x dx. So let's start with the first one. How do we integrate the function tan x dx? Now we know that tan x is equal to sine x over cos x. Now whenever you want to find the integral of a function which is presented in the quotient form, the first thing you need to check out is if the numerator is equal to the derivative of the denominator, or better still, if the numerator is a multiple or a sub-multiple of the denominator. Now looking at this function, we have the numerator to be sine x and the denominator to be cos x. Now if you should differentiate the denominator, which is cos x, with respect to x, you have negative sine x, and you realize that the numerator is a constant multiple of the result we have here. So we can use the approach we are talking about. So the first thing is to let the letter z be equal to the denominator, which is cos x. Next, you want to find the derivative of this denominator, or cos x, with respect to x. So that is equal to negative sine x, and then you want to make dx the subject. So we have dx to be equal to, so basically I'm going to interchange dx and the negative sine x. So that becomes dz divided by negative sine x. Now let's put these two into this integral. So that is basically going to be equal to, we have the integral of sine x divided by cos x, and that is z, times dx. We have dx to be dz divided by negative sine x. Now basically what we are doing here is to write the integral, or express the integral in terms of z. So the next thing is we are going to cancel out sine x and then sine x, and then we are left with we pull out negative outside, or better still we can say -1, and then we have the integral of 1 over z times dz. Now we know that the integral of 1 over z dz is equal to ln of the absolute value of z plus c. So basically we have this to be negative times ln of the absolute value of z. Now we have z to be cos x, so absolute value of cos x plus c. So basically that is the integral of tan x dx. Now again, from the properties of logarithm, we know that negative ln of absolute value of cos x can as well be written as ln of 1 over cos x. So this is the absolute value of 1 over cos x. So we have the negative out, and then we are going to replace that with 1 over cos x. Now we know that 1 over cos x is sec x. So we have ln of the absolute value of sec x. So you can as well say that tan x dx is also equal to ln times the absolute value of sec x plus c. So any one of these two is correct. So for example, if you want to find the integral, an example, if you want to find the integral of the function for tan 10x dx, so basically you pull out 4, you have the integral of tan 10x dx, that is basically equal to, you have 4 times, this becomes, you can choose to have, first of all, let's try to differentiate 10x, and that gives 10. So that appears at the denominator. Don't forget that we have a negative here. So let's bring out the negative outside here. And then we have times ln of the absolute value of cos 10x plus c. So that is equal to 2 goes here 2 times, 2 goes here 5 times. We are left with negative 2 over 5 times ln of the absolute value of cos 10x plus c. Again, if you want to use ln of the absolute value of sec x plus that one, you also have that to be equal to 4 times, so you are using this, so we have, you are going to differentiate 10x as usual. You have 10, so that becomes 1 over 10 times ln of sec 10x plus c. 2 goes here 2 times, 2 goes here 5 times, so we have 2 over 5 times ln of the absolute value of sec 10x plus c. Now let's move on to the second one, that is the integral of cot x dx. So using the same approach to evaluate the integral of cot x dx, then basically you are going to get that to be equal to ln of sine x plus c. So ln of the absolute value of sine x plus c. If you do it correctly, that is what you are going to get. So let's say we have an example. Let's say you want to find the integral of cot 2x dx. That is basically equal to, we are going to differentiate 2x, and then we have 2, and that appears at the denominator. So we have 1 over 2 times ln of the absolute value of sine x. Here we have 2x, so of sine 2x, and then plus c. So basically that is what we are expected to obtain for this very example. Again, let's talk about the integral of sec x dx, as well as the integral of cosec x dx. Now for the last two, we are going to expatiate more on that in the subsequent lessons. Now for the integral of sec x dx, that results to ln of the absolute value of sec x plus tan x plus c. So the absolute value of ln of sec x plus tan x plus c, and then the integral of cosec x dx is also equal to ln of the absolute value of cosec x minus cot x plus c. Now let's move on as we focus on integrals that result into inverse trig functions. So considering the integrals that results into inverse trig functions, we have a number of them here, and we are going to try a couple of examples. So let's take our first example. We want to find the integral of the function 3 divided by the square root of 9 minus x squared. So let's try to solve this. So first of all, because 3 is a constant, we can pull out 3, and then we have the integral of 1 over, we have the square root of, now we can as well think of 9 as 3 square minus x squared. Now let's try to compare this expression to any of the 6 equations we have here. Now you realize that this can be compared to as the integral of 1 over the square root of a square minus x squared. So we have 1 over the square root of a square minus x squared, which corresponds to sine inverse of x over a plus c. So here you realize that we have a to be 3. So let's proceed. So we are going to have this to be equal to 3 times, we are going to have sine inverse of x over a, so times sine inverse of x, that is x over a. We have a to be 3 plus c. So this is basically equal to, we have 3 sine inverse of x over 3 plus c. Now let's move ahead. So let's take example 2. Here we want to find the integral of the function 2 over x squared plus 16 dx. So again we can pull out 2, and then we have the integral of 1 over x squared plus 4 squared. Now we can as well write this as 4 squared plus x squared, because addition is commutative. So comparing this to any of the 6 we have here, we have 1 over a squared plus x squared. So 1 over a squared plus x squared, that corresponds to 1 over a times tan inverse of x over a. So that becomes 1 over, we have a to be 4, so 1 over 4 times tan inverse of x over 4 plus c. So 2 goes here once, 2 goes here 2 times, we have equals 1 over 2 times tan inverse of x over 4 plus c. Now let's move on to 3. We have the integral of 10 over x times the square root of x squared minus 2 square. So this is also equal to, we pull out 10, we have 1 over x times the square root of x square minus 2 square dx, and you realize that this corresponds to 1 over a sec inverse of x over a plus c. So that becomes 10 times 1 over, we have a to be 2, so 2 times sec inverse of x over 2 plus c. 2 goes here once, 2 goes here 5 times, that is equal to 5 sec inverse of x over 2 plus c.